Now, the potential energy of a dipole in a uniform external field. So, potential energy of the dipole ಎಷ್ಟು ಹಾಗಿದ್ರೆ ಏನು external field ಅಲ್ಲಿ ಅಂತ ನೋಡೋಣ. So, imagine that we kept a dipole in external electric field E. So, E is the external electric field. Theta is the angle between the dipole moment and external electric field. So, plus Q and minus Q are the charges of dipole. So force acting on minus Q charge will be in this direction. Force acting on plus Q charge will be in this direction. Okay. ಇವಾಗ ನಾವು torque acting on the dipole placed in an external field is given by tau is equal to P into E into sin theta ಅಂತ ನೋಡಿದ್ದೇವೆ ಅಲ್ವಾ ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದ್ದೇವೆ. So even though force acting on both charges will be 0, so ಇಲ್ಲಿ ನೋಡಿ ಇದನ್ನ ಪ್ಲಸ್ ಎಫ್ ಅಂತ ತಕೊಂಡ್ರೆ ಇದನ್ನ ಮೈನಸ್ ಎಫ್ ಅಂತ ತಕೊಂಡ್ರೆ ನೆಟ್ ಫೋರ್ಸ್ ವಿಲ್ ಬಿ 0 ಅಲ್ವಾ. ನೆಟ್ ಫೋರ್ಸ್ ಆಕ್ಟಿಂಗ್ ಆನ್ ದ ಡೈಪೋಲ್ ವಿಲ್ ಬಿ 0. ನೆಟ್ ಫೋರ್ಸ್ ಆನ್ ಡೈಪೋಲ್ equal to 0 ಅಲ್ವಾ. ಬಟ್ torque is not equal to 0. ಯಾಕೆ ಹೇಳಿ, even though net force on the dipole equal to 0, but torque is not equal to 0 because force acting on different point. So same line alli force act ಆಗ್ತಾ ಇಲ್ಲ, forces acting on different point. Their force is not acting in same line. That's why torque will be there on dipole. So that torque is given by P into E into sin theta. P andre dipole moment, E andre electric field, sin theta is the angle between this dipole moment, sin theta is the angle, okay, angle between this dipole moment and electric field. So andre torque can be written as cross product of P into E. So torque is equal to P into P cross E ಅಂತ ಬರೀಬಹುದು, P into E into sin theta ಅಲ್ವಾ. ಸೊ ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಗೊತ್ತು ನಮಗೆ. ಓಕೆ. ಸೊ ದಿಸ್ torque rotates the dipole. Due to this torque acting on the dipole, there will be rotational motion. Okay. It causes or dipole experiences rotational motion due to this torque. Torque ಹೇಗೆ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ? ಡ್ಯೂ ಟು external electric field. Okay. ಈಗ small amount of work done in rotating the dipole through an angle d theta without acceleration is given by, as you know, torque causes rotational motion of dipole. So work done in rotating dipole through very small angle d theta ಎಷ್ಟಾಗಿರುತ್ತೆ ಹಂಗಿದ್ರೆ dw is equal to tau into d theta ಅಂತ ಬರೀಬಹುದು. ಸೊ tau into d theta. Okay. Tau can be written as ಏನು ಇಕ್ವೇಶನ್ ನಂಬರ್ 1 ನಲ್ಲಿ ಏನಂತ ಬರ್ದಿದ್ದೀವಿ? P into E into sin theta ಅಂತ ಬರ್ದಿದ್ದೀವಿ ಅಲ್ವಾ. ಸೊ dw can be written as PE sin theta into d theta ಅಂತ ಬರೀಬಹುದು ಅಲ್ವಾ. ಸೊ ಈಗ ಟೋಟಲ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್ ಇನ್ rotating the dipole from theta 1 to theta angle is given by, so small angle d theta rotate ಮಾಡಕ್ಕೆ ನಮಗೆ work done will be dw. So total work done is equal to integration of dw. So in dw na ನಾವು integrate ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ if we add the large number of dw, then we will get the integration of dw, that is total work done in rotating the dipole from angle theta 1 to theta 2 is given by integration of dw from theta 2 to theta 1. So just substitute the value of dw as Pe into sin theta d theta. Pe ಅನ್ನ ಹೊರಗಡೆ ತೆಗೆದ್ರೆ ಇಂಟಿಗ್ರೇಷನ್ ಸೈನ್ ಇಂದ ಹೊರಗಡೆ ತೆಗೆದ್ರೆ ಇಂಟಿಗ್ರೇಷನ್ ಸೈನ್ ಒಳಗಡೆ sin theta d theta ಉಳಿತು. ಸೊ W can be written as P into integration of sine theta d theta into from theta 2 to theta 1. So ಇದನ್ನ ನಾವು integrate ಮಾಡಿದಾಗ integration of sine theta is minus cos theta. Range is from theta 2 to theta 1. So theta 1 and theta 2 ಅನ್ನ substitute ಮಾಡಿದಾಗ ನಮಗೆ potential energy can be written as the total work done can be written as P into E into cos theta 1 minus cos theta 2 ಅಂತ ಬರಿಬಹುದು. This work done is rotated in the dipole as potential energy. Okay, so this is the potential energy also. Total work done is equal to potential energy. It can be written as U anta baritane potential energy anna. U can be written as P into E into cos theta 1 minus cos theta 2. So ಈಗ special case anna nodi. If initially the dipole is oriented perpendicular to the direction of electric field. So ee riti. Okay. So idu dipole moment direction. This is the direction of P. Okay. This is the direction of E. So if dipole moment is in perpendicular direction to electric field, ಆವಾಗ theta 1 ಏನಾಗುತ್ತೆ 90 ಡಿಗ್ರಿ ಅಂತ ತಗೋಬಹುದು ನಾವು ಅಲ್ವಾ. ಸೊ theta 1 ಏನಾಗುತ್ತೆ 90 ಡಿಗ್ರಿ. ಆಮೇಲೆ ಏನ್ ಮಾಡ್ಬೇಕು, ಈ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಅನ್ನ ಅಂದ್ರೆ ಇಲ್ಲಿ ಮೈನಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಪ್ಲಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಸೊ ಈ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಅನ್ನ ನಾವು ಸ್ಮಾಲ್ ಆಂಗಲ್ ಇಂದ ರೊಟೇಟ್ ಮಾಡಿದಾಗ, ಸೊ theta 1 ಇಂದ theta 2 ಆಂಗಲ್ ಗೆ ರೊಟೇಟ್ ಮಾಡಿದಾಗ, ಸೊ theta 2 equal to theta ಅಂತ ತಗೊಂಡ್ರೆ potential energy of the dipole will be, so theta 1 ಎಷ್ಟು ತಗೊಂಡಿದ್ವಿ 90 ಡಿಗ್ರಿ ಅಂತ ಮಾಡಿದ್ರೆ cos 90 is 0 ಅಂತ ಬರುತ್ತೆ. cos 90 is 0, correct. cos 90 is 0 ಅಂತ ಬಂದ್ರೆ, so final expression is minus P into cos theta. This is the potential energy. Okay, expression for potential energy when dipole is kept in external electric field. Thank you.